Hello, welcome to this video. In this video we'll be looking at some examples of ratio theorem and some other examples of vectors. So, in the previous video we looked at ratio theorem and what it is, so we'll look at some examples of that. Points A and B have coordinates 3, 2, -1 and -4, 3, 5 respectively. We've been asked to find the coordinates of point C, which divides AB, first internally in the ratio 2 to 3. So you could have a small sketch of this, so you could skip right straight to the calculation if you know what you're doing. This sketch is not to scale, but if you have the points A and B just there, then point C should be around there, which divides AB in the ratio 2 to 3. Now we know that OC, the position vector of point C, should be given by 3 times OA. 3 is associated with B, so multiplied by the position vector of A, plus 2 times OB divided by 3 plus 2, like we saw in the previous video. So it should be 3 times position vector of A is 3, 2, -1 plus 2 times -4, 3, 5, and we're dividing all this by 5, and this should give you 1 out of 5, 12 out of 5, and then 7 out of 5. This is a position vector, and they ask for the coordinates of point C. So then you'd have to say that C is at 1 out of 5, 12 out of 5, 7 out of 5. Or you can write them in decimals if you like. Okay, let's look at the second part, in the ratio of 3 to -2. Okay, so that tells us that we're looking at external division. So we could have our point A there, then we'll move to our point C, and then our point B will be somewhere there, such that I'm looking at 3 and then -2. So I'll have OC as 3 times OB plus -2 times OA. You switch the association again, divide by 3 plus -2. So this is going to be 3 times -4, 3, 5 minus 2 times 3, 2, -1, divide by 1, yeah, and this is equal to -18, 5, 17. Once again you write it as coordinates, because that's what it asks for. So C will be at -18, 5, 17, and that's how you'd handle such a question. Okay, let's look at another example. The points T and S have coordinates 2, -5, 7, and 1, 1, -1 respectively. Find the coordinates of R, which divide ST in the ratio 3 to 1. So being told in the ratio 3 to 1, so we can assume that that's internal, because none of the parts of the ratio is negative. So we'll have our dividing ST. Remember, order is important. ST is not the same as TS. So 3 to 1 look like something like that, where our point R is in the middle, and so the coordinates, the position vector of R will be given by 3 times OT plus OS, 1 times OS, divided by 3 plus 1. This is going to be 3 times position vector of T is 2, -5, 7 plus 1, 1, -1, divide by 4, and that gives us 7 over 4, -7 over 2, and then 5. And of course you have to write this as coordinates. So you'd say therefore R is at 7 over 4, -7 over 2, 5, unless you've been asked for the position vector. Okay, let's look at this part B. So part B says externally in the ratio 4 to 3. Now this is tricky because we don't know where to put the negative. The question says externally, so we know that one of the parts should be negative. Thing is, it doesn't matter which one you put it on, you'd still get the same answer. Like I said, if you have S and T, you might be tempted to put the negative on the 3, because you want to move to the right, and then 4, let's say 4 to the right, and then 3 to the left. So that's going to be a plus 4 and a minus 3. And so you'd have that OR is given by 4 times OT minus 3 times OS out of 4 minus 3. It's going to be 4 times 2 negative 5 7 minus 3 times 1 1 negative 1 divided by 1, which gives us 5 negative 23 30 31. So this will be what you get as a position vector, and therefore you know R is at 5 negative 23 31. Now what if you wanted to use your S, you know, the negative on the 4 instead? If you were to sketch it, that would mean probably your S is on the right and you're moving like 4 to the left. That's where your R is, and then 3 to the right, such that your T is somewhere. Your T is somewhere there. And so you'd have negative 4 and a 3. Realize that you have OR as negative 4 times OT plus 3 times OS out of negative 4 plus 3, which is exactly what you have here, because you've simply just multiplied the numerator and denominator by negative 1. So it's exactly the same, and so your coordinates of point R would be exactly the same, 5 negative 23 and 31. And so it doesn't matter whether you put the negative on the 4 or on the 3, you'll still get the same answer, which is what I said in the previous video. So you don't even need to do the sketches. The sketch is just for you to have a visual, you know, representation of what it might look like, but you don't need them if you know what to do. Okay, so one look at some more general examples, maybe with or without using ratio theorem, some of which you're familiar with from O level. Let's look at this one. So in the figure below, OA is equal to A, the vector A, and OB is equal to the vector B. When you see it in bold, you know that it represents a vector. Yeah? So C lies on OA, where OC is 2/3 of OA, B is the midpoint of AB, and OD and BC intersect at M. So part A asks us to find two vector expressions for OM, taking OM to be P times OD and BM to be Q times BC, where P and Q are scalars. Okay, so we can first do that. We have that OM is equal to P times OD. Let me just write this on the next slide. So OM is equal to P times OD. What do we know OD is? So OD is, as you can see, OB plus BD. Yeah. These questions are really just about you being observant and using that to establish equations and expressions. So we have that OD is equal to OB plus BD. Okay, we know what OB is because it's B, but what is BD? We've been told that D is the midpoint of AB, so that means that BD should be a half of BA. So this is going to be OB plus a half BA. But we know our BA because BA is BO plus OA, which is negative B plus A, or A minus B. This is going to be B plus a half times A minus B, which is in fact half A plus a half B. So we've got an expression for OD. We know that OM is P times this, so we'll have that OM is a half PA plus a half PB. Okay. Now one look at the other equation, which is BM is equal to Q BC. So what is BC? So we'll have to find what BC is first. So you can see that BC is BO plus OC. So we can move with that. BC is BO plus OC. We've been given that BM is Q times BC. So BC is BO plus OC. We know that BO is negative B, and OC in the question is 2/3 of OA. Yeah, so we shall use 2/3 of OA, which is 2/3 of A. So it should be 2/3 A minus B. And so we want to get, okay, so that means that BM is equal to Q times 2/3 of A minus B, which is 2/3 Q times A minus QB. Now here we know that OM is, we want two expressions for OM, that's what the question asks for. So OM here would be P times a half A plus a half B, which would be a half PA plus a half PB. And here to get OM would have to be OB plus BM. OB is B, BM is 2/3 of Q times A minus Q times B, which is in fact 2/3 of Q times A plus 1 minus Q times B. So we have the two expressions for OM, that means our part A is complete. Now we've been asked in part B to find the values of P and Q, and hence the ratios OM to MD and BM to BC. Okay, so to find P and Q, we have two expressions for OM, and they're both in terms of A and B. So we can compare the coefficients of A and B and then be able to find P and Q and then the ratios required. So here we'll have a half times P is equal to 2/3 of Q. If you just compare the coefficients of the vector A, a half P is equal to 2/3 Q. If we compare the coefficients of vector B, we'll have a half P is equal to 1 minus Q. So here we have two equations in P and Q which we can solve simultaneously. And you realize that when you solve these equations simultaneously, you'll get your P as 4 out of 5 and your Q as 3 out of 5. So if you're being asked to calculate the ratio of the vector OM to MD, so OM to MD would be, if you look at OM is from what we've been told, OM is P of OD, and we got that P is 4 out of 5, and so that means that MD would be a fifth of OD, so this would just be 4 to 1. And then the ratio BM to MC, you know that BM is 3/5 of BC, that means MC is 2/5 of BC, that means that BM to MC is in fact 3 to 2, and that's how you'd handle such a question. Okay, so this question has been left for you to try out. It's a bit similar to the previous question. We use ratios and different equations to just get relationships between the different vectors involved. So try it out and proceed.